Today, we're going to tackle three of the biggest buzzwords in tech: artificial intelligence, machine learning, and deep learning. You'll see how they're all connected, and more importantly, how they're already changing our world in ways you might not even realize. Okay, so let's start with a question that kind of gets right to the heart of it. Have you ever wondered how an app can guess you're drawing a cat before you've even finished the whiskers? It's not magic, I promise. It's a powerful technology that has learned by analyzing millions of other drawings to recognize the core patterns of what makes a cat, well, a cat. And believe me, this technology is everywhere. It's inside the self-driving car that recognizes a stop sign. It's behind the movie recommendation that just knows you'll love that obscure sci-fi flick. And it's even in advanced medical systems that can spot tiny details in an X-ray a human might miss. It's already woven right into the fabric of our world. All right, so let's zoom out and start with the big picture. What exactly is this huge umbrella term we call artificial intelligence, or AI? You can think of AI as the grand, overarching vision, right? It's this huge field of computer science that's all about building smart machines. The ultimate goal here is to create systems that can perceive, reason, and learn, basically to do stuff that normally requires human intelligence. Okay, so if AI is the big dream, then machine learning, well, that's one of the most powerful ways we actually get there. And to really get it, let's think of it like a chef learning how to cook. So yeah, machine learning is a huge part of AI. But what makes it so different? Well, instead of giving a computer a super rigid, step-by-step recipe for every single task, we give it experience in the form of data, and we let it figure out the patterns and the rules for itself. And the whole process kind of follows a simple recipe, which is pretty cool. First, you have your ingredients. That's your data. Things like images or numbers or text. Then you have the recipe itself, which is the learning algorithm. That's the set of instructions for how to find patterns. And the finished dish, that's what we call the trained model, a system that's ready to go out and make predictions. But, any good chef will tell you, you can't just dump your ingredients into a pot and hope for the best. The prep work, the mise en place is everything, and it's the exact same for machine learning. See, a machine doesn't look at a photo and see a cat. It just sees this massive grid of pixel values, literally millions of numbers. To learn anything useful from that, the raw data has to be prepped and organized first. And this is where, for a long time, one of the most crucial and human-heavy parts of the whole process came in. It's called feature engineering. Instead of just feeding the machine raw, messy data, we use our own smarts to pick out and create the most important variables, or features, for the algorithm to look at. For ages, this was the most time-consuming part of the whole shebang. So instead of just throwing millions of pixels at the machine, we might design features like, let's see, the pointiness of the ears, or the shape of the eyes, or maybe the ratio of the distance between the eyes and the nose. These are the meaningful clues that give the algorithm a real fighting chance. All right, so our ingredients are prepped and ready to go. Now, how does our machine chef actually learn the recipe? Turns out there are three main ways it can go about it. First up, you've got supervised learning. And honestly, the best way to think about this is like learning from a cookbook, but with a teacher looking over your shoulder, checking your work. The machine gets data that already has the answer key built in. So, for example, we might feed it thousands and thousands of images, and every single one is explicitly labeled chicken or duck. The machine just keeps studying these examples over and over until it finally learns the patterns that distinguish one from the other. That way, it can correctly identify a new photo all on its own. Okay, next up is unsupervised learning. Now, in this kitchen, the chef is all on their own. No recipes, no labels. The whole point is to just discover hidden structures and patterns in the ingredients completely by itself. So in this case, we just give the machine a huge pile of photos with zero labels. It starts to analyze them, looking for similarities, and begins grouping or clustering them together on its own. And this isn't some abstract idea. This is the magic behind how your phone might organize your photos into albums, or how a streaming service recommends a movie based on what other people with similar tastes have watched. And last but not least, we've got reinforcement learning. I like to think of this one as a chef who's constantly perfecting a dish based on customer reviews. It's all about learning through trial and error in a live environment. It's pretty straightforward, really. The AI agent tries something, and it gets feedback, either a reward or a punishment. As you can see here, touching the fire, that's a penalty. But finding the battery, that's a reward. You let this run for millions and millions of trials, and eventually it learns the absolute best strategy to get the most rewards. And this is exactly how we train AIs to master super complex games like chess or Go. Ah, right. Now let's get to the really cutting-edge stuff. We're moving on to the master chef of the AI kitchen, deep learning. This is the technique that creates dishes nobody even thought were possible. So deep learning is actually a very specialized kind of machine learning. It uses these things called artificial neural networks, which, as the name suggests, are structures loosely inspired by our own brains. And what makes them deep? Well, it's because they have tons of layers of these artificial neurons stacked on top of each other, and that allows for way more complex learning. And that layered structure is absolutely the key. Now, here's the really cool part. This setup allows the model to learn these incredibly complex patterns directly from the raw data. Remember that whole difficult human-driven process of feature engineering we talked about? Well, deep learning pretty much automates it. But, and this is a big but, all that power comes at a cost. It requires a massive kitchen. We're talking immense computational power and a giant pantry, which means just enormous amounts of data to learn from. So that brings us to the big question, right? After all this, AI, machine learning, feature engineering, deep learning, what's the one single, indispensable ingredient that fuels this entire revolution? The one thing it absolutely cannot live without. It all comes down to data. Everything we've talked about, from the simplest little model to the most complex deep neural network, it's all fundamentally driven by data. The more high-quality, relevant data you can feed the machine, the more experience it gets and the smarter it can become. Data truly is the lifeblood of modern AI.